Time, position, velocity. Walking to the school at different speed. Well, the graph here is slightly different from the graph in the previous example. So let's try to review a few things which we learned in the previous example. So what we learned there was how to find or how to read time and distance from the graph and how to find velocity from the graph, right? So let's look into those aspects before getting down to some new concepts. So here we have a graph where along the x-axis we have independent variable time in minutes, and along the y-axis we have the dependent variable d, distance, in meters. So as the time goes by, the position changes and the distance we find is changing with time. So distance is dependent on time. So to write my story, I'm taking this graph as a distance versus time for Dave. And I'm assuming that Dave starts from home and is going to the school. So let's say this origin is point A for us, and A happens to be home of Dave. So the position here is 0, time here is 0. The starting point is 0, 0. At point B, can you read the position of point B? When we say position, then what we are trying to say is what is the x-axis and what is the y-axis, or x-coordinate and y-coordinates for B. So here along the x-axis we have time, so we have 8 minutes, and along the y-axis we have distance, which is 200 meters. So point B can be written as 8, 200. So that becomes the position of point B, right? Similarly, can you tell me the position at point C? Position at point C is 4, 8, 12 minutes, right? 12, distance of 100, 200, 200. So the position at C is 12, 24. How about position at D? Position at D can be time. Time is this much, which is 4, 8, 12, 16, 20, and the distance, which is 600. Okay, 600. So that is the position of D. Let's call this point E. Position of E is 32 along the x-axis, which is time in minutes, and along the y we have distance, and distance covered will be 600 meters. 32, 600. So from a graph, distance versus time, we can read distance dependent on time, right? So at A it is 0, 0. Let me write 0, 0. At B it is 8, 200. At C it is 12, 200. At D it is 20, 600, and at E it is 32, 600. So these are the positions which we can read straight from the graph, right? And what we can find, last time we found average velocity. So let's read the graph once again and let's make a story now. The story is distance versus time for Dave. So the storyline could be like this. So at time t equals to 0, Dave starts from his house and moves along this path, traveling at a steady pace, and he covers 20 meters in first 8 minutes, right? And then he stops for a while, and that is 4 minutes. And now realizing that he is getting late, he moves faster towards the school, and along the path CD he covers a distance from 200 to 600, that is a distance of 400 meters in a span of 4 and 8 minutes, right? So along the leg CD, the distance of 400 is covered in 8 minutes. Along BC, distance moved is 0, so he's just standing at a point, therefore the speed is 0. From A to B, distance covered is 200 meters in 8 minutes, right? And slope, as you know, is rise over run. Rise in this case is change in distance, and run in this case is change in time. Okay. Now, as an exercise here, let's find the slope for different legs in this particular graph. So the first leg, A to B, the slope is rise, change in height over change in run, change in distance over change in time. So this change is 200 meters, right? So let's write 200 in the numerator. Slope of AB, slope of leg AB is change in distance, which is 200, divided by change in time, which is 8. And that gives us 8 times 2 is 16, and 8 times 5 is 40. 25, and the units are unit of distance, which is meters, and unit of time, which is in minutes. So we get units as meters per minute. So that slope actually gives us speed of Dave along AB, right? So in first 8 minutes, Dave is moving at a constant speed of 25 meters per minute, right? Now from B to C, the change in distance is 200 minus 200, which is 0. And change in time is from 12 minus 8, which is 4. 0 over 4 is 0. So the slope is 0. And the speed is 0 meters per minute. Now along the leg CD, change in distance is 600 minus 200, right? 600 minus 200. See, that is the triangle which we are considering now. So the change in distance is 600. 600 is this distance minus 200. And change in time is 20 minus 12. Correct? So we can write change in distance is 600 minus 200, which is 400, divided by 20 minus 12, that is 8. So when you divide 400 by 8, 8 times 5 is 40, and then 0. So it's 50 meters per minute, right? So what we notice here is that Dave is walking to the school in the first leg at the speed of 25 meters per minute. Then he stops for 4 minutes. Then he stops. So what we notice here is that the Dave walks in the first leg from A to B at a speed of 25 meters per minute. Then he stops for 4 minutes and walks faster towards the school at a rate of 50 meters per minute, right? So all these informations help us to describe our graph better, right? So we can now say that the story could be that Dave starts from home at the instance when time is 0. He covers first 200 meters in 8 minutes. So along this path, the speed is 25 meters per minute. Then he stops for 4 minutes, that is B to C, and walks faster towards the school at a steady pace of 50 meters per minute, covering distance of another 400 meters in 8 minutes. So he reaches school, which is 600 meters away from home, in 20 minutes, right? So that is how you can tell your story, right? Now from D to E, it just shows that Dave stays in the school all along, right? So he doesn't move, right? So speed is 0, distance does not change, right? So these additional informations which we got here help us to describe the situation in a better way, correct? So try to make your own story and describe the given graph. As an added exercise, I would like you now to do a few more things. And that is, first, let's try to find average speed between the time A to D, right? Average speed between A to D, right? So to find the average speed, speed is change in distance. Let me write delta as change in distance, right? Change in distance over delta will denote change in time, right? If you go from A to D, the change in distance is 600, right? The big triangle. So you can draw a big triangle here. 600 minus 0. So it is 600, and change in time will be 20. So 600 by 20 will give you 30. Units are meters per minute. Meters per minute. So you can also find average speed of Dave as he goes from home to school, stopping in between for 4 minutes. Do you see that? So we can say. Another thing which you notice here is that the slope of these lines are different. Here we have a line with a slope of 25, and then we have a horizontal line with a slope of 0, and then we have a much steeper line with a slope of 50. So if the line is horizontal, then we can correlate it to velocity or speed. For a horizontal line, what do you think is the speed? A horizontal line on a distance time graph shows 0 speed. Okay, that means the person or the thing is not moving. It is stand still. So make a note of this. That is 0 slope. 0 slope means stand still. No change in position, right? No change in position. Position remains same, and that means 0 speed. 0 speed, right? So 0 slope means 0 speed, and steeper the slope, faster the speed, right? Here the slope was 25 and then it was 50. That means the speed doubled on the leg CD as compared to leg AB because it was much steeper. So along the path OP, Dave was slower than as compared to CD, right? So these are a few more things which we can see from the graph. So from the slope we can make out how fast a thing is moving, right? Or how fast a position is changing. So that is what we can find. So make your own story and try to find some more new things from this graph. I hope now you understand how to read distance and time from a distance time graph, how to narrate it in a form of a story, and how to calculate things like slope and speed from the graph. Thank you.